You've seen the headlines. Every few months, NASA or the European Space Agency announces a massive breakthrough. Scientists discover Earth 2.0, new habitable planet found. It paints a comforting picture in your mind. A backup planet, a place with blue oceans, green trees, and a yellow sun. A new home for humanity when this one finally runs out of time. But there is a terrifying catch. The term habitable doesn't mean what you think it means. In fact, if you were to step foot on the surface of the most promising Earth 2.0 candidates we've ever found, you wouldn't survive for more than a few agonizing seconds. Today, we are going to travel to the TRAPPIST-1 system and Proxima Centauri b, the crown jewels of exoplanet discovery. I'm going to show you exactly what it would feel like to stand on their surfaces. But be warned, by the end of this video, you will realize that the universe is far more hostile than we ever imagined. And the biggest trap of Earth 2.0 is that if we ever manage to land there, we'll never ever be able to leave. To understand why these new worlds are absolute nightmares, you first have to understand how scientists look for them. Astronomers use something called the Goldilocks zone. It's the specific distance from a star where a planet is not too hot and not too cold, but just right for liquid water to exist on the surface. On Earth, where there is water, there is life. So, when astronomers find a rock in the Goldilocks zone, the media immediately brands it as Earth 2.0. Here is the problem. Our sun is a yellow dwarf. It is large, stable, and relatively calm. But 70% of all the stars in the Milky Way are red dwarfs. They're tiny, dim, and incredibly chaotic. Because red dwarfs are so cold and dim, their Goldilocks zone is pushed right up against the star. Imagine sitting around a campfire. If the fire is roaring, you sit far back to stay warm. But if the fire is just a pile of dying embers, you have to shuffle your chair right up to the edge of the pit just to keep from freezing. That is exactly what is happening with planets like Proxima b and TRAPPIST-1e. They are orbiting so close to their stars that a single year only lasts a few days. And being that close to a star triggers a bizarre, terrifying law of astrophysics known as tidal locking. Because the planet is so incredibly close to the gravitational pull of its star, its rotation slows down until it perfectly matches its orbit. What does that mean for you? It means the planet no longer has days or nights. If you stood on the day side of Earth 2.0, the sun would be permanently frozen in the exact same spot in the sky forever. The heat would be relentless. The oceans on this side of the planet would literally boil into the atmosphere, creating hurricane-force winds of scalding steam. The ground would be baked into a barren, cracked desert. But what if you walked to the other side of the planet, the night side? You would step into permanent pitch-black darkness, a side of the planet that has not seen a single ray of sunlight for billions of years. The temperature would plunge to hundreds of degrees below zero. Any water would be frozen into a permanent shell of solid ice. Half the world is an oven. The other half is a freezer. But scientists believe there is a tiny loophole, a sliver of hope. Right on the border between the boiling day and the freezing night, there is a thin ring of land wrapped around the planet. It is called the Terminator Line, or, more appropriately, the Twilight Zone. If humanity were to colonize a tidally locked Earth 2.0, the Terminator Line is the only place we could survive. If you stood here, the sun would be perpetually stuck on the horizon. It would look like a permanent sunset that never fades. But it wouldn't be peaceful, because the day side is boiling hot and the night side is freezing cold. The planet's atmosphere would be pushed to its absolute limits. Hot air from the day side would constantly rush toward the night side to cool down. This would create global, never-ending, hurricane-force winds. We are talking about gales blowing at hundreds of miles per hour, non-stop, day in and day out. You wouldn't be building nice wooden cabins on Earth to point zero. You would be building aerodynamic bunkers bolted deep into the bedrock, just to keep from being blown into the freezing abyss of the night side. But let's say we engineer our way out of that. Let's say we build reinforced dome cities on the Terminator line. There is an even deadlier threat waiting in the sky above you. Remember how I said red dwarf stars are chaotic? Because they are so small, their internal convection is violent. They frequently unleash massive stellar flares, bursts of radiation and plasma, that are thousands of times more powerful than anything our own sun produces. In 2017, astronomers watching Proxima Centauri observed a flare so massive that the star became 1,000 times brighter in a matter of seconds. If you are living on a planet right next to that star, you are taking a direct hit from a cosmic shotgun. These flares would bombard the planet with lethal doses of UV and X-ray radiation. Worse, over millions of years, these constant solar storms would likely strip the planet's atmosphere completely away. Without an atmosphere, you have no air to breathe, no pressure to keep water liquid, and absolutely zero protection from the vacuum of space. You wouldn't be standing on Earth 2.0, you would be standing on an irradiated, dead rock, slowly being sterilized by an angry star. But let's play devil's advocate. What if the planet has an impossibly strong magnetic field? What if it manages to hold on to its atmosphere and we build radiation-proof cities? Even then, Earth 2.0 holds one final, inescapable trap. And it's the reason why, if you land there, you can never come home. When astronomers look for exoplanets, they often find worlds that are rocky like Earth, but much, much larger. We call them super-Earths. A super-Earth might have 2, 3, or even 10 times the mass of our planet. And that mass creates a gravitational pull that would turn the human body into its own worst enemy. If you landed on a super-Earth with just 3 times the mass of our planet, your body weight would triple. If you weigh 180 pounds on Earth, you would instantly weigh 540 pounds the second you stepped out of your ship. Every step would feel like you are carrying a refrigerator on your back. Your heart would have to work 3 times as hard just to pump blood to your brain. You would be exhausted just standing still. Over time, your joints would degrade, your spine would compress, and your cardiovascular system would likely fail. But the real horror of a super-Earth isn't what it does to your body. It's what it does to your spaceship. In aerospace engineering, there is a harsh mathematical reality known as the tyranny of the rocket equation. To escape a planet's gravity, you need fuel, but fuel is heavy. So to carry that extra fuel, you need more fuel. To escape Earth's gravity, a rocket is roughly 90% fuel. Only a tiny fraction is the actual payload and astronauts. Now, try to leave a super-Earth. Escape velocity is so monstrously high that chemical rockets, the kind we use today, are physically incapable of lifting off. Could build a rocket the size of a skyscraper, fill it entirely with rocket fuel, and it still wouldn't be enough to break free of the planet's gravity well. A super-Earth is a cosmic roach motel. You can check in, but you can never check out. Any astronauts brave enough to land on a super-Earth would be permanently marooned. They would be prisoners of gravity, forced to live out the rest of their lives, looking up at a sky they can never return to. Boiling oceans, lethal radiation, crushing gravity, permanent darkness. When you look at the reality of Earth 2.0, it begs a very obvious question. Why are we spending billions of dollars and decades of research looking for them? If these planets are hellscapes that humans can never survive on, why do we care? Because we aren't looking for a new home for humanity. We are looking for proof that we are not alone. Life is incredibly resilient. On our own planet, we find life thriving in the boiling toxic vents at the bottom of the ocean. We find microbes surviving in the freezing ice of Antarctica. We find bacteria that can survive the vacuum of space. If life can adapt to the extremes of Earth, it is entirely possible that alien life has adapted to the nightmare conditions of a tidally locked red dwarf planet. Perhaps in the twilight zone of Proxima b, strange flora uses the infrared light of the red dwarf to photosynthesize. Perhaps beneath the ice of the dark side, geothermal vents harbor ecosystems of blind alien creatures. Finding Earth 2.0 isn't about packing our bags and moving. It's about answering the oldest question in human history. Are we the only ones here? When we look at the hostility of the universe, the boiling heat, the crushing gravity, the lethal radiation, it should make you look at our own planet with a profound sense of gratitude. We don't need an Earth 2.0 because the Earth we have right now is a mathematical miracle. It is a perfect sanctuary floating in a universe trying to kill us. And we need to protect it because there is no backup plan.